Hello and greetings to everyone. We have the following questions to answer. The questions are on polynomials. Question 1 says, given that f of x is equal to negative x to the power 5 plus 2x cubed minus 3x to the power 2 minus x plus 4, g of x is equal to 11x to the power 4 plus 5x cubed minus 11x minus 25, and each of x is equal to x minus 1. These three functions we have here, they are polynomial functions. The first one is of degree 5. The highest power of the variable x is 5. The second one is of degree 4. And the third one is of degree 1. This one is a linear polynomial. We are to find I f of x plus g of x, 2i f of x minus g of x, 3i f of x times h of x. IV, we have to find g of x divided by h of x. Let's take solution. We have f of x equal to negative x to the power 5 plus 2x cubed minus 3x squared minus x plus 4. We have g of x as 11x to the power 4 plus 5x cubed minus 11x minus 25, and each of x is equal to x minus 1. Question I says we should find f of x plus g of x. For us to add these two functions, these two polynomial functions, first step, we need to write out the polynomial f of x in descending powers of the variable x. That means we start from the highest power to the smallest, writing down all the powers. We know, for example, here we have x to the power 5, so the next power should be x to the power 4. Here x to the power 4, the term in x to the power 4 is absent. We know 0 times x to the power 4 is the same as 0. This will give us a negative x to the power 5. We're going to add the term 0x to the power 4 plus 2x cubed. Here there's no difference. Nothing new has been done. We are just doing this so that we can easily add these two polynomials. Minus 3x squared minus the term in x to the power 1 plus the constant term. Now we can look at the powers. Say the highest power is 5, next 4, 3, 2, 1, 0. Next, we need now to write out the polynomial g of x. G of x will simply be equal to, we know the polynomial g of x of degree 4. So the term in x to the power 5 is absent. We can write down 0x to the power 5. Next plus next term in x to the power 4, 11x to the power 4. Next will be the term in x to the power 3 plus 5x cubed. Next will be the term in x squared, which will simply be plus, is absent, plus 0x squared. Next will be the term in x minus 11x. And lastly, the constant term. We have to add these two polynomials. So what I'm going to do is, I'll draw a horizontal line as such. After drawing the horizontal line, I'll put the addition sign in front. At the left hand side, I'll write this down, f of x plus g of x will simply be equal to, then I will add the terms on each vertical alignment. Means on this vertical line, I'll add all these terms, I'll add these terms, I'll add these terms, I'll add these terms, and so on, right down to the constant term. I know negative x to the power 5 plus 0x to the power 5 will remain the same as negative x to the power 5. Next, 0x to the power 4 plus 11x to the power 4 will give us plus 11x to the power 4. Next, 2x cubed plus 5x cubed. 2 plus 5 gives us 7. So this will give us plus 7x cubed. Next, negative 3x squared plus 0x squared. This will give us negative 3x squared. Next, negative x plus negative x plus negative 11x. This will simply be the same as negative x. Positive, negative, we know negative will stay, minus 11x. This will simply be equal to, here we can factor the negative sign. Factor negative 1, this will give us negative x. This will give us x plus 11x. This will simply be equal to negative x plus 11x will give us 12x. So the answer will simply be negative 12x. Next, we have 4 plus negative 25. 4 plus negative 25 is the same as 4 minus 25, which is simply equal to negative 21. Therefore, f of x plus g of x will simply be equal to negative x to the power 5 plus 11x to the power 4 plus 7x cubed minus 3x squared minus 12x minus 21. We are going to underline the result. Two horizontal lines. Next, now we are going to answer 2i. For 2i, we have f of x minus g of x. We are still going to do the same thing. F of x is the same as negative x to the power 5. I will copy, plus 0x to the power 4 plus 2x cubed minus 3x squared minus x plus 4. G of x is equal to 0x to the power 5 plus 11x to the power 4 plus 5x cubed plus 0x squared minus 11x minus 25. We are going to draw the horizontal line, and we put the minus sign. At the left hand side, we are going to write f of x minus g of x. It will simply be equal to, now if we take negative 5x, negative x to the power 5 minus 0x to the power 5, this will simply give us negative x to the power 5. 0x to the power 4 minus 11x to the power 4, this will simply give us negative 11x to the power 4. Next, 2x cubed minus 5x cubed. We know 2 minus 5 gives us negative 3. So this will give us negative 3x cubed. Next, negative 3x squared minus 0x squared simply remain negative 3x squared. Next, negative x minus negative 11x. Negative x minus negative 11x. This will simply give us negative x. Negative negative becomes positive. So plus 11x. This will give us, their signs are different. So the result will take the sign of the larger term, which is 11x. The result will be positive. This will be the same as 11x minus x, which gives us 10x plus 10x. Next, 4 minus negative 25. 4 minus negative 25. Simply this as 4. Negative negative becomes positive. 4 plus 25 gives us 29. It's 29. And we are done with the subtraction of the two polynomials. Next, we go to 3. The 3 we have to find f of x times h of x. Now f of x is the polynomial. We are going to put in a bracket as such. Negative x to the power 5 plus 2x cubed minus 3x squared minus x plus 4. We have to multiply it by the polynomial. I'll put the second polynomial in the bracket. We know already these two brackets are for multiplication by the polynomial x minus 1. Now we need to expand the brackets. I will take each of the terms here in the polynomial f of x and I'll multiply them by the first term of the polynomial h of x, which is x. And I'll do the same thing. I'll take all the terms of the polynomial f of x, I'll multiply them by negative 1. Negative x to the power 5 times x. Applying the rules of indices, we are simply going to add the power, then we maintain the negative sign. This will give us negative x to the power 6. Next, negative x to the power 5 times negative 1 gives us positive. We know negative times negative becomes positive. X to the power 5. We are done with x to the power, negative x to the power 5. Going on to the next term, 2x cubed. Positive 2x cubed times x will give us plus 2x to the power 4. 2x cubed times negative 1 will give us negative 2x cubed. We are done with this term. We go now to negative 3x squared. Negative 3x squared times x will give us negative 3x cubed. Negative 3x squared times negative 1 will give us positive 3x squared. We are done with this term. We go now to the next term, negative x. Negative x times x will give us negative x squared. Negative x times negative 1 will give us positive x. We go now to the next term, the constant term 4. Positive 4 times x will give us plus 4x. And lastly, positive 4 times negative 1 will give us negative 4. Next, what we have to do is we just need to simplify the terms. That means we add like terms or we subtract the like terms. Here, this is the only term we have in x to the power 6. Negative x to the power 6. The next term we have will be terms in x to the power 5. And this is the only term in x to the power 5 plus x to the power 5. Next, we have 2x to the power 4, and this is the only term in x to the power 4. We're going to write it plus 2x to the power 4. Next, we have negative 2x cubed minus 3x cubed. These two terms are in x to the power 3, so they are like terms. No, negative 2 minus 3 gives us negative 5x cubed. Next, we have 3x squared. Positive 3x squared minus x squared will give us plus 2x squared. Next, we go now to the terms in x. Positive x plus 4x will give us plus 5x. And negative 4 is the only constant term, minus 4. And we are done with the multiplication of the two polynomials. Underline the result. Next, the next one we have g of x divided by h of x. IV, we have g of x divided by h of x. This would be the same as g of x is the polynomial 11 x to the power 4 plus 5x cubed minus 11x minus 25. We have to divide this polynomial by h of x, which is x minus 1. In this case, we are going to make use of the method of long division. This is the dividend, what we have for the numerator here, and this is the divisor, what we have at the denominator. We are going to send the divisor out and the dividend in. This will give us the divisor is x minus 1. X minus 1 goes out. We write in the dividend, which is g of x, and g of x is 11x to the power 4 plus 5x to the power 3. The term in x squared is absent, so we are going to include it by putting plus 0x squared minus 11x minus the constant term, which is 25, the constant. Now we are going to perform the division. We are going to take 11x to the power 4 divided by x. 11x to the power 4 divided by x. This will simply give us 11x to the power 4 minus 1, which is simply 11x cubed. We are applying the rules of indices here. So this will give us 11x cubed. Next, we are going to take 11x cubed times x. It gives us 11x to the power 4. 11x cubed times negative 1 will give us negative 11x cubed. Here we draw our horizontal line, then we subtract. 11x to the power 4 minus 11x to the power 4 gives 0. It will be needless for us writing the 0 here, so we are just going to leave a blank space. 5x cubed minus negative 11x cubed. This will be the same as 5x cubed minus negative 11x cubed. This will simply be the same as 5x cubed. Negative negative becomes positive, plus 11x cubed. This will simply be equal to, 5 plus 11 gives us 16. This will give us 16x cubed. Next, we are going to bring down the term in x squared. We are going to bring this down. So this will give us plus 0x squared. We are going to take 16x cubed divided by x. This will simply give us plus 16x squared. 16x squared times x will give us 16x cubed. 16x squared times negative 1 will give us negative 16x squared. When we subtract, 16x cubed minus 16x cubed gives us 0. 0x squared minus negative 16x squared. 0x squared minus negative 16x squared is going to be equal to 0x squared. Negative negative becomes positive plus 16x squared, which is simply equal to 16x squared. Here we have 16x squared. Next, we are going to bring down the term negative 11x. We're going to bring it down, minus 11x. 16x squared divided by x gives us plus 16x. 16x times x gives us 16x squared. 16x times negative 1 gives us negative 16x. Next, we subtract. 16x squared minus 16x squared gives us 0. Negative 11x minus negative 11x minus negative 16x will simply be equal to negative 11x. Negative negative becomes positive. This will give us negative 11x plus 16x is the same as 16x minus 11x, which is simply equal to 5x. This will give us 5x. Next, we are going to bring down the constant term, negative 25, to meet 5x. 5x divided by x will give us positive 5. 5x divided by x. X will cancel, x will simply be left with 5. Next, we have to multiply 5 times x will give us 5x. 5 times negative 1 will give us negative 5. Then we subtract. 5x minus 5x gives us 0. Negative 25 minus negative 5 will simply be equal to negative 25 plus 5. This will simply be equal to, if we compare these two numbers in terms of magnitude, the larger number will be negative 25. So in this case, our result will simply take the sign, the negative sign. We are going to subtract the smaller number from the larger number. 25 minus 5. This will simply give us negative 20. The result will be negative. Here, we are left with negative 20. And negative 20 here is independent of the variable x. That means we are going to end our division here at this level. This negative 20 will simply be our remainder after performing this division. Therefore, we are going to conclude now. Therefore, divide the polynomials. If you divide g of x by h of x, the quotient will simply be this. Will simply be 11x cubed plus 16x squared plus 16x plus 5 plus the remainder part. For the remainder we have negative 20, and this negative 20 is to be divided by the polynomial, be divided by x minus 1. This will simply give us 11x cubed plus 16x squared plus 16 plus 5, like this. I'll put it this way in brackets. Positive negative, we know negative will dominate, minus 20 over x minus, and we are done with the division. Next, now we go to question 2. Question 2, which says find the remainder when the polynomial. Question 2, we have to find the remainder when the polynomial f of x equal to 3x to the power 4 minus 5x to the power 3 plus 2x squared minus 3x plus 25 is divided by, when this polynomial is divided by g of x, which is equal to 2x minus 1. In this case, for us to find this remainder, we can make use of this method of long division, but this will be much time consuming and very stressful. It will be very fast if we make use of the remainder theorem. The remainder theorem states that if we have a polynomial f of x and we have to divide this polynomial by another polynomial g of x, let's assume g of x is the same as x minus e. For us to get the remainder r, let me just write it in full. The remainder will simply be obtained by, first thing, we are going to equate the polynomial g of x to 0. That is, if g of x is equal to 0, x minus e will be equal to 0. This will give us x to be e. If you transfer negative e to the right hand side, it becomes positive. For us to get the remainder will simply be equal to f of, where we have x here, we have to replace x with e. This will give us f of e. F of e is simply the remainder. When we replace x with e, Then we carry out the necessary simplifications. That's all about the remainder theorem. Now in this case, we have to find the remainder when the polynomial f of x is divided by g of x, which is equal to 2x minus 1. First thing, we need to find the value of x, that value of x, which we have to insert in the polynomial function f of x. First, if you equate the polynomial g of x to 0, then this will give us 2x minus 1 to be equal to 0. Next, we have to look for the value of x. This will give us 2x. We make 2x the surrogate formula, so we are going to transfer negative 1 to the right hand side, which becomes positive 1. Next thing, for us to get the value of x, we have to divide all through by the coefficient of x, which is 2. Right here by 2 is equal to, so this will give us x to be equal to a half. Next, we know f of x is equal to 3x to the power 4 minus 5x cubed plus 2x squared minus 8x plus 25. For us to get the remainder will simply be given by, to make use of the remainder theorem. The remainder will simply be given by f of a. In this case, we know our a is a half. So this will be equal to f of a half. And the function f of x, anywhere we see x, we have to replace x with a half. This will give us 3 times a half raised to the power 4 minus 5 times a half raised to the power 3 plus 2 times a half squared minus 8 times a half plus 25. If we take a half raised to the power 4, it's simply the same as 1 raised to the power 4 over 2 raised to the power 4. You know 1 raised to any power remains 1 over 2 raised to the power 4 is simply 2 times 2 times 2. This will simply be equal to 1 over 2 times 2 gives us 4 times 2 gives us 8 times 2, 16. So this will give us 3 times 1 over 16 minus 5 times 1 all over. We know 1 raised to the power 3 remains 1. 2 raised to the power 3 gives us 8 plus 2 times 1 over 4 minus, if you take 8 times a half, we know 8 here is the size 8 over 1. You can simplify. This will give us 2 over here 1, 2 over here 4 times. This will give us negative 4 plus 25. This will simply be equal to 3 times 1 over 16 will give us 3 over 16 minus 5 times 1, 8 will give us 5 over 8 plus 2 times 1 quarter will give us 1 over 2 a half. Negative 4 plus 25 will give us 21 plus 21. Next, we have to add these fractions. First thing, we need to start by finding the LCM. We know 21 here is the size 21 over 1. We need to get the LCM of 16, 8, and 2. We know the LCM will simply be 16. 16 is a multiple of 2. 16 is a multiple of 8. The LCM will simply be 16. 16 divided by 16 gives us 1. 1 times 3, 3. Bring down the operation sign, which is minus. 16 divided by 8 gives us 2. 2 times 5, 10. Bring down the operation sign, which is plus. 16 divided by 2 gives us 8. 8 times 1, 8. Plus 16 divided by 1 remains 16. 16 times 21. Multiply. 1 times 1 gives us, we are going to fix a 0, 1. Times 2, 2. 6 times 1, 6. 6 times 2 gives 12. We add 6, 3, 3. So this will give us 336. Next thing that we have to simplify. 3 minus 10 will give us negative 7. Negative 7 plus 8 will give us 1. 1 plus 336 will give us 337 all over 16. This is the remainder. We're going to leave it as such as an improper fraction. The remainder will simply be 337 over 16. Next, we proceed now to the next question. Question 3, we have the question which goes the polynomial f of x equal to 3x cubed plus 2x squared plus ax plus b leaves a remainder of negative 8 when divided by x minus 1. Given that x minus 2 is a factor of the polynomial f of x, find I the values of the unknowns a and b, 2I the factorization of the polynomial f of x, 3I the values of x for which f of x is equal to 0. Let's write out the polynomial f of x is equal to x cubed plus 2x squared plus ax plus b. We are told that it leaves a remainder of negative 8 when divided by x minus 1. First thing, we are going to equate x minus 1 to 0. Then we find the value of x. This will give us x to be 1. By making use of the remainder theorem, we know the remainder is simply the same as f of 1, it's simply equal to f of 1. From the question, we have been told that the remainder is negative 8. We simply have negative 8 to be equal to f of 1. Anywhere I see x, I'll replace x with 1. 1 cubed plus 2 times 1 squared plus a times 1 plus b. This will give us negative 8 to be equal to 1. 1 cubed, 1 times 1 times 1 remains 1 plus 1 squared is 1 times 2, 2 plus a times 1 gives us a plus b. This will give us negative 8 to be equal to 1 plus 2 gives us 3 plus a plus b. This will simply imply that a plus b, we want a plus b to be alone on one side. We are going to transfer 3 this way, which becomes negative 3. This will give us negative 8 minus 3. This will simply give us a plus b to be equal to negative 8 minus 3. They have the same signs. We just add them in negative sign, which is negative 11. We're going to call this one equation 1. Next, we have been told that x minus 2 is a factor of the polynomial. x minus 2 is a factor of f of x. If x minus 2 is a factor of f of x, that means if we apply the remainder theorem, the remainder will simply be equal to 0. We are going to equate x minus 2 to 0. Then we find the value of x. Then x will simply be equal to, we are going to transfer negative 2 to the right hand side, which becomes positive. Next, in this case, we have been told that x minus 2 is a factor. If x minus 2 is a factor, that means when we divide the polynomial f of x by x minus 2, the remainder should be 0. And this gives us the what we call the factor theorem. In this case now, f of 2 should be equal to 0 here. f of 2 should be equal to 0. I'll just write beside according to the factor theorem. Here it is according to the remainder theorem. Next, now we can proceed. We need to find f of 2. Anywhere we see x, we have to replace x with 2. And we know this must be equal to 0. This will give us 2 cubed plus 2 times 2 squared plus a times 2 plus b should be equal to 0. 2 cubed, 2 times 2 times 2 gives us 8 plus 2 times 2 squared is simply 4 plus a times 2 gives us 2a plus b equal to 0. This will give us 8 plus 8 plus 2a plus b is equal to 0. 8 plus 8 gives us 16 plus 2a plus b is equal to 0. Then we need to make 2a plus b the surrogate formula. 2a plus b will simply be equal to negative 16. We call this one equation 2. We have two equations with two unknowns. These are two simultaneous linear equations. We can solve these equations by making use of the method of elimination. Looking at the two equations, we can see that the coefficient of b in equation 1 and equation 2 are the same, 1, 1. So if we subtract the two equations, we'll be able to eliminate the variable b. Let's solve the equations. We have a plus b is equal to negative 11. We have 2a plus b is equal to negative 16. We are going to subtract these two equations to eliminate the variable b. Subtract a minus a gives us negative a minus 2a gives us negative a. B minus b disappears, 0 will be equal to negative 11 minus negative 16. This is simply equal to negative 11. When we have two negative signs, it becomes positive plus 16. This will simply be the same as 16 minus 11, which is simply equal to 5. We have negative a to be equal to 5. Negative a equal to 5. For us to get a, we are simply going to divide all through by the equation of negative a, which is negative 1. Negative a divided by negative 1 is simply equal to 5 divided by negative 1. This will give us a to be equal to negative 5. So this will simply imply that a will be equal to negative 5 as the value for a. I'll underline the value for a. Since we know the value for a already, it is very easy now for us to find the value of b by using equation 1. Using equation 1, you can decide to use equation 2. Using equation 1, we can find the value of b. We know that we know equation 1 is simply a plus b equal to negative 11. Then we know the value of a, we are just from calculating a, which is negative 5. We are going to replace with negative 5 plus b equal to negative 11. This will give us b. We need to make b the surrogate formula. Negative 11 plus 5. This will simply give us b to be equal to negative 11 plus 5. Will give us a result of negative 6. Let's underline it. Therefore, now we can write our polynomial f of x replacing the values of a and b. Therefore, f of x is simply equal to x cubed plus 2x squared. We know a plus ax. We know the value for a is negative 5, so minus 5x plus b. We know the value for b is negative 6 minus 6. This is our polynomial f of x with the values of a and b. Next, go to 2i. For 2i, it says that we should factorize the polynomial f of x. We need the factorization of that polynomial. For us to get the factorization of this polynomial, first we need to divide the polynomial by one of its factors to get a quotient which is quadratic. When we obtain the quotient which is quadratic, the quadratic function, we can proceed to factorize that quotient. Then we are going to obtain our polynomial as a product of linear factors. In this case, we have been told in the question that x minus 2 is a factor of that polynomial. So we are going to dividing f of x equal to x cubed plus 2x squared minus 5x minus 6 by one of its factors, which is x minus 2. When we perform this division, our remainder must be 0, since x minus 2 is a factor of f of x. In this case, we are going to make use of the method of long division, because if you apply the factor theorem here, if you put x to be 2, you always obtain 0, which is not useful. In this case, let's divide x, the polynomial f of x, by x minus 2, x cubed plus 2x squared minus 5x minus 6. X cubed divided by x gives us x squared. X squared times x gives us x cubed. X squared times negative 2 gives us negative 2x squared. We subtract x cubed minus x cubed 0. 2x squared minus negative 2x squared. Now the two negative signs will become positive. So this will give us 2x squared plus 2x squared, which is 4x squared. Next, we have to bring down minus 5x. 4x squared divided by x will give us plus 4x. 4x times x will give us 4x squared. 4x times negative 2 will give us negative 8x. Next, we subtract. 4x squared minus 4x squared will give us 0. Negative 5x minus negative 8x. This will simply be the same as negative 5x. Negative negative becomes positive plus 8x. This will simply give us 8x minus 5x, which is 3x. This will give us 3x. Bring down negative 6. 3x divided by x will give us 3. 3 times x gives us 3x. 3 times negative 2 gives us negative 6. Next, we subtract. 3x minus 3x gives 0. Negative 6 minus negative 6 will simply be the same as negative 6 plus 6, which is the same as 6 minus 6, which is 0, which will give us 0. Now, the next thing is, you'll see, since the remainder is 0, it simply proves that x minus 2 is a factor of f of x. We can express our polynomial. Let's write it down as such. It simply means we have, if we divide x cubed plus 2x squared minus 5x minus 6, if we divide this polynomial by x minus 2, we will simply obtain a result which is the quotient of x squared plus 4x plus 3. We know this one is over 1. For us to get this our polynomial, we are simply going to cross multiply, or we multiply through by the LCM, which is x minus 2. We cross multiply x cubed plus 2x squared minus 5x minus 6. When you multiply this by 1, it remains unchanged. Will simply be equal to this. Will multiply this x minus 2 times x squared plus 4x plus 3. Now we are going to factorize the quadratic expression x squared plus 4x plus 3. Factorizing Factorizing x squared plus 4x plus 3. For us to factorize x squared plus 4x plus 3, let me just write it beside here. X squared plus 4x plus 3. First thing, we need two factors of 3 such that when we add them, their sum is equal to the coefficient of x, which is 4, and their product, that means when we multiply those two factors, their product is equal to 3. The sum is positive, the product is positive, so it means that the two factors of 3 must be positive factors of 3. If you write out the positive factors of 3, we have 1, 3. 3 is a prime number. If you take 1 plus 3, it gives us 4. 1 times 3 is equal to 3. We are going to write down this our quadratic expression, x squared plus 4x plus 3. This is an expression. It becomes an equation when we have an equal to sign. For example, if you have something like this, equal to 0, this is a quadratic equation. Without an equal to sign, it is an expression. This will simply be the same as x squared plus, I'll replace 4 with 1 plus 3, then times x plus 3. This will simply be equal to x squared plus, I'll expand this bracket, 1 times x remains x, plus 3 times x gives us 3x plus 3. Next, I'll take the terms in pairs, then I'll factor out the common. I'll factor out what's common. X squared and x here, x is common. I know x times x will give us x squared plus x times 1 will give us x plus these two terms here. 3 is common, so I'll factor out x. I know 3 times x will give us 3x plus 3 times 1 will give us 3. Now we have two terms. The two terms we have, x plus 1 is common, so I'll factor out x plus 1. Now x plus 1 times x will give us x times x plus 1, this, plus, I know x plus 1 times 3 will give us this. We are done with the factorization of the quadratic expression. Next thing we have to do now is we are going back to this. We are going back to our polynomial. We are going to replace the quadratic expression x squared plus 4x plus 3 with x plus 1 times x plus 3. Therefore, f of x will simply be equal to x minus 2 times x plus 1 times x plus 3. So this is the factorization of the polynomial f of x. You can see it is a product of its linear factors. Here the highest power of x is 1, the highest power of x is 1, highest power of x is 1. Next, now we go to 3i. 3i says that we should find the values of x for which f of x equal to 0. F of x is equal to 0, then if f of x is equal to 0, then it simply means this product of linear factors will be equal to 0, which simply means that either, because x cannot take 3 values at the same time, either x plus 2, x minus 2, not plus 2, let me cancel this, x minus 2 is equal to 0, or x plus 1 is equal to 0, or x plus 3 is equal to 0. Here, if we make x the subject of formula, x will simply be equal to 2, or x will simply be equal to -1, or x will simply be equal to -3. Next, we are going to write down the conclusion. Therefore, f of x is equal to 0 for x belonging to the set. You can write it as such: for x belonging to the set -3, -1, 2. That means if x takes a value of -3, f of x will be 0. If x takes a value of -1, f of x will be 0. If x takes a value of 2, f of x will be 0. So this is our solution set for this our polynomial f of x as such. If you don't want to present the solution this way, you can decide to present it as such. You can either say x is equal to -3 or -1 or 2. It simply means that x takes one value at a time. X cannot take two values at a time. And we are done with the solution of the questions. If in case there are any worries, make sure you leave your questions at the comment section. You like the video, you share, and you subscribe to this YouTube channel. Thank you very much for watching.